All right, today we're going to do step functions. Sometimes in real life, functions are represented by a combination of equations corresponding to a part of the domain. Such functions are called piecewise, which we already graphed. Remember, we did a piece of a line, another piece of a line, etc. This is an example of a type of piecewise function, which is called a step function. It's got pieces. So here's a real-life example. Center High School held a 4-hour fundraising pledge drive. The students organizing the drive counted the total money raised at the end of each hour. So they weren't counting in between. The results are shown in the graph. How much money had the student raised after 2 hours? Well, you go to 2 hours, and if you go up from 2, you see an open hole there, which means that's not the answer. You got to continue on up till you get to the solid dot, which is at 1,000. That's when they counted up what they got. How much money did they raise in all? Well, that would be at the end of 4 hours when they finished counting it, and that's at 1,800. If x is the number of hours of the drive that have passed, then the function f of x shown by the graph gives the number of dollars raised. What is the f of 3.5? Well, after 3.5 hours, they're still sitting at, $1,500. Okay, so they aren't counting it in between. On what interval does the f of x equal 400? So from what time period did they have $400? That would be from 1 to, and it's including 1 hour, up to 2, and then it's not including 2 because at 2 hours they counted and they had actually have 1,000, so it doesn't include the 2. It's only over the interval 1 to 2. What is the domain of the function? Well, the domain includes everything from 0 hours to 4 hours. So it includes no time to 4, 0 to 4 hours. But the range is limited. It cannot be written in a continuous form because it's not continuous. So when you have data that's not continuous, you use a bracket. And you say, well, what are the values of y? They were either 0, no money, 400, after 2 hours, 1,000, after 3 hours, they were at 1,500, and after 4 hours, they ended up with a total of 1,800. Those are your range values. So sometimes in a step function, or when you do a step function, the range is limited. The domain is not, because it's a function. These are notation that you might see in a text for the greatest integer function. It's also called the round down function. The definition of the function's on page 102 if you'd like to go read it. I'm just going to talk about what it does. Where the domain is from negative infinity to infinity and the range is all integers. Do you know what an integer is? What do you think of when you think of a number line? What are the labels? Positives and negatives. Okay, and it's the whole positive, negative number. Whole numbers are actually not integers. That's a subgroup of the integers. But integers do include the negatives. Whole numbers do not. So it's numbers like -3, -2, -1, 0, 1, 2, and goes on in both directions. Okay, it's like the normal numbers that you'd put on a number line. Okay, so that's going to be your range. So the values are always these kind of numbers for the greatest integer function. So if I wanted to evaluate -3, that's what it would look like. Notice that these are not absolute value bars. It's like more of a bracket, kind of like our hard bracket look. Often you might see it look like that. And I'm just saying, you don't have to write that down really. You just need to know that this doesn't mean absolute value. It means the greatest integer. Or round down. So now I'm going to teach you how to round down. Well, is -3 already an integer? Yes, it is. So the round down or rounding -3 down is -3. It is itself. But if you went to 2.5, you would round down to 2. Okay, it's always an integer. But what happens when you round down to negative 1.8? Negative 1 or negative 2? Negative 2. Okay, so if it helps, you want to think like this. Negative 1.8 would be between here. Rounding down would have been negative 2. Okay, 1/2. What do you round down to? 0. And negative 1/2 rounds down to negative 1. We're going to graph this situation now. It says it's a 4-piecer. All of these mean basically y equals 1, y equals 2, y equals 3, y equals 4. So it's going to have some steps. It says that y is 1 when x is between 0 and 1, but not including 1. So what does that look like? Well, if you went to 0, you are going for x, then the value if y is 1. If you're between 0 and 1, now when you get to 1, you're not really including the value of 1. So you have to put an open hole at 1, 1. And then you would connect it because it stays 1 between 0 and 1. All right? The next part is saying if x is between 1 and 2, the value of the function is 2. So that's going to be a solid dot at 1, 2, and then over to 2, open hole at 2. When x is between 2 and 3, the value of the function is 3. So that would be a solid dot at 2, 3, and then over an open circle on 3, 3. And then it jumps to 4 when x is between 3 and 4. Okay, it doesn't include 4, so open hole. That is the entire set of steps for this function. It doesn't go on any further because this one was defining it as 3 separate pieces of lines. I mean, 4 separate pieces of lines. But this is going to be different. And before we do this one, I don't know why I would like to have changed the order, so I'm going to go to the next one, number 10, because this is the parent function for the step function. All right, so what we're going to do is I want you to understand where I'm getting the values from. So I'm going to make a little t-chart. I'm going to start with 0. And if I take what's 0 rounded down, it is 0. Okay. If I put in 1, 1 rounded down is 1. If I put in, what if I put in 1.5? 1.5 rounded down is 1. So now if I put in 2 rounded down is 2. Okay, so sorry that that doesn't look separated right there. So what happens is this is going to be the first step function, and I'm not going to keep on putting in stuff in there because I'm going to show you how to do it without having to do that. So we go to 0, 0, and then over, it's going to stay that way. Everything between 0 and 1 will round down to 0. So that's why you get a little segment. But when you hit 1, it jumps up to 1, 1. So we need an open hole here at 1. Your steps are going to look like little balloons sideways. With me? All right, so I'm going to go over now. When I hit 2, I have to have an open hole, and then I step up. When I hit 3, I have to have an open hole, and I step up, and I'm going to erase this because I want all of your graphs to be continued on as far as you can do them on the graph. And that reason is I want to know that you can back this up. This is not fully done because this one keeps going. I actually could jump up here and put a dot because that point would be the value when x is 4, 4, 4. Now, if I go backwards, I can just go down here to -1 open hole and then go to the left. I'm just continuing the picture in a way. And you don't have to have big old dots at, I don't care if you just have little sticks, but I try to show that I'm starting here, continuing over with an open hole. And this one would actually go again all the way to the corner. Now, I'll explain why I want you to keep going. Isn't that different than this? Okay, this one had stopped. The one we did does not. All right, now we're going to find out what doing something in the front does. If you recall from yesterday's lesson, we did absolute value yesterday. So when there was a number out front, it made the y's go up faster, right? Made it stretch vertically faster. It was a vertical stretch. If I sit here and just put in my head, put in 0, I get 0. And now I want to see, okay, if I put in 1, I would get 2 times 1, which is 2. All right, so I know it stays flat, and then an open hole when I get to 1, and it jumps up to 2. And then it goes over, open hole, when I get to 2 for x, and then it jumps up to what? 2 times 2, which would be 4. Do you see what the number in front is doing to the steps? Okay, I'll show you back here for a second. See this one? How far is between my steps vertically? 1 unit between my stairs, right, if you will. That's when A is 1. This one we're doing right now has a 2 in front of it. The steps are 2 apart. Okay, so this is going to jump up 2, over, jump up 2, and over. And then down 2, open hole left. I'm just backing it up now. My last step will be from -2 over to -1. So your open hole should be on the right. All right, solid dots on the left, and then a bar has to connect them. If these are not connected, it's completely wrong. Okay? Okay, so we're going to go on now to number 11. So how far apart are the steps? Okay, 3 apart. Right, so let's start and just use your head to know where to begin. If you put in 0, you'd get 0. That means when we get over to 1, we're going to have an open hole, because when I put in 1, I'm going to get 3. And there's the beginning of your steps. Now you know how to do the pattern, because there are 3 between each step. I can only do 3 of these in this section, and then I can go backwards one more time. And that's all we can graph for that one. Okay, so let's also, on the next one, number 12, think about what this number will be doing. It's inside with the x value. Okay, when we talked about the shifts on the absolute value graphs and others, we call that an H, right? H was a horizontal, H for horizontal shift, because it's by the x. It's affecting what happens with the x. So basically, it's the opposite of what you see. It's -8. So this should be a shift to the graph that we started with right to. So on number 10, oops, it's right there, hello. I'm thinking this is going to shift, this whole thing slides over 2. Let's try it. You don't have to remember that, but I do want you to start knowing what the shifts were. If I ask what is the shift, vertical or horizontal, you should be able to start telling me very soon. Okay, so if I put in 0, or what, I don't like I suggested before, I would get -2, and -2 rounded down is -2. And if I were to put in 1, 1 minus 2 would be -1, which is rounded down as -1. If I hit 0, -2, and I go over, make my step, there's only a 1 in front of there, so the steps should be 1 apart. Jump up to 1, -1, go over, 2, over, up, 1, and over. Now I'm going to show you, when we look at the picture, from number 10 to number 12, do you see that it actually has slid over to the right? Bye, good luck. See this picture? It slid over now. It doesn't look right. What makes it look different? So, see how these boxes are? It's that one's got a smaller grid than this one. But it really is, this whole graph right here shifted to the right too. All right, what do you think a number out here is going to do? It's not by the x, so that's going to be a vertical shift. That would be up 1 vertically. So I'm not going to worry about that so much as I'm just going to start plugging in. I'm going to say, okay, if I put in 0, I would get 1. So 0, 1. That's my starting spot. I'm using red because I think it shows up on here the best for you to see. I kind of felt like changing color, but I know it shows well. All right, if I put in 1, I would get 2. So let's see. Let's begin our steps. Start at 0, 1, go over, make your open hole. There's a value of 1, so it should jump up 1 between its steps, and it does. Okay, so just continue making steps. Remember not to connect vertically. There should be openness between the steps. And keep going backwards, following the pattern. Do I need to put an open dot down here in the corner? Like if I wanted to show the whole graph? But what does it mean though when it's an open dot? It's not there. It's not included, so I wouldn't bother. I mean, it's not there. There's no value there. Okay. Oh, trick question. All right. What do you think the negative 2 does? It should be a space between our steps are going to be 2 apart. That's what that thing does. Steps will be 2 apart. What else is it going to do? Reflects the graph over the x-axis. But what does that do to the values? Or what? I'm trying to say it a different way. What would it do to your stairs? Well, these are going what? And these are going to come down. Okay, that's what it's going to do. The steps are going to go down, okay? 2 apart, and they're going to go down. All right, but we need to figure out where to start. So let's put in 0 and think. Negative 2 times 0 would be 0, plus 3 would be 0, 3. Okay, and you could pop in another number. This always helps. If I put in 1, negative 2 times, well, 1 rounded down is 1. Negative 2 times 1 would be negative 2, plus 3 would be 1. 1, 1. Oh, okay, so my steps it goes to the right and then open, and then when it hit 1, it went down 2. Oh, that's what I suspected was going to happen. Then go over, open hole, down 2. And I keep going. And then the reverse will be up 2, open hole, back over to the left. And that's all you can fit on that one. 6 steps. You'll get more into stuff by X inside there when you're in pre-calc. So let's kind of guess what might happen. What's the half of X going to have an effect on? So this number here, stretched it this way vertically, and it was outside of the bars, the greatest integer bars. So if it's inside, it's going to do something to it horizontally. So it's either going to squeeze it in or stretch it out. Right, now we're going to find out because it's not so intuitive. If I put in 0, I'm going to get 1. If I put in 1 in here, half of 1 is 1/2. What is 1/2 rounded down? 0. So when I put in 1, I'm going to get 0 plus 1, which is 1. If I put in 2, half of 2 is 1. 1 plus 1 is 2. So let me just see what's going on here. 0, 1, 1, 1. So it kept going, right? And then when it got to 2, it jumped to 2. So that means it didn't jump until I went 2 spots. So it stretched it horizontally. It got wider. The step got wider. So next it's going to be a two pieces across to 4 before it jumps up another step. The steps are 1 apart because the A value is 1. And it went up vertically from the x-axis 1 because of the 1 outside there. And the 1/2 stretches it horizontally, twice as big. So it kind of didn't do what we thought it might have done. I think most of you were thinking it's going to shrink it, right? Because it was a fraction, but it's actually stretching it. All right, open hole here, back it up. Open hole, back it up. All right, so I guess if the inside of here had been 2x, it would have cut the interval in half horizontally. Ooh, that would have been really hard to graph. Glad we didn't do that one. All right, 16. The negative is going to make the steps go down. That's it. All right, so if you're starting with 0, and when you get to 1, you have your open hole, you're going to drop down to -1. This should be a really fast one for us to graph. Now we got more stuff going on. Okay, so our steps should be 3 apart. And this thing shifts it up 1. So let's just figure out where we begin by plugging in 0. 0, 1. When we get over to 1, we would get 3 plus 1, 4, which is making our steps 3 apart, just like we expected. Now you can just follow the pattern after you get the first couple of steps. And I can only put on here 1, 2, 3, 4 steps. Pretty easy. All right, what do you think? Which way was this one going to shift? If you ask for the shift, it's by x. It should say -h, so it's left. Yep, horizontally left 2. All right, but we can always just plug in 0 and figure out where to begin and then follow a pattern. A is 1, so it's going to be a 1 between the steps. 0, 2 is where it begins. Oh, I made a wrong place. I went too far. Okay, when I get to 1, it's going to jump up to 3. Then when I talk about the shift, it's the regular step function, just y equals the greatest integer function. I just put a point in the wrong place because I'm talking. It will look like it has been shifted left too. Gosh, I gotta make a lot of pieces on there. Holy cow. So instead of starting here, it slid over to the left. Because the normal greatest integer function, see, I could even show it by shifting it. That's how the normal greatest, or the parent function starts. So this one is just sliding it over to. Anyway, do it however makes it easiest for you, just as long as you start learning what the translations are. All right, half of x, that means the steps are going to be only half apart. Okay, so if I put in 0, get 0, 1, I get a half. So my steps are only 1/2 apart. Kind of hard to fit it on here. Oh, my hole, that doesn't look open. Good enough. Did I get them all by halves? I think I did. Yeah, did. Okay, -3 steps are going to go down. Put in 0, you get 0. When you hit 1, you're going to go jump down to -3. So the steps are 3 apart. Not going to have to make too many of these. You only can fit 4 on it. All right, why don't you do number 21 and we'll check it. Go for it. Okay, check and make sure you did it right. Okay. That was the last example. So your assignment is for tonight. Oh, except, no, I'm sorry. I have one more thing to show you. Actually, 2. Yep, I got the admission ticket thing to do, and I want to show you how to do this on the calculator. Or actually just to see the graphs. Okay. Let's just pop in the one that we just, well, I'll show you 2 of them. So when you go into y equals on the graphing calculator, make sure nothing is black at the top, which means plots are on. So if any of these are highlighted, what I mean by that is if it looks like that, then you want to turn it off by going up to it and hit enter and then arrow back down. Okay, if we wanted to do this last problem, it was the greatest integer of x plus 1 minus 3, right? So we need to find what that greatest integer thing is. Hit the math button, arrow to the right, type of number, ABS, absolute value, that's the first one. 5 is the greatest integer function. So choose choice 5. You will see this, INT. Push X, which is next to the alpha button. I'll just do into the X one right now. The parent graph, okay? Now I'm going to hit zoom 6. Please stay with me. There's your parent graph. If you have an older system calculator, it might look like they're connected. I think most of us have something that's not going to do that though, so that's good. Go back to y equals. Let's do this 2 times. So I'm going to hit 2, math, over to NUM, 5. Let's do X. What was one of them we did? Okay, I don't care. Close the parenthesis, plus 5, just so you can see what happens. hit graph. See how the stairs are further apart and everything? Because we did 2, so there's 2 spaces between the stairs. Steep stairs. And then if you want, I mean, you could go put in a negative, -3, math, choice 5. Oh, I didn't go to the number. Type that again. -3, math, arrow to NUM, choice 5, and then I'll just do X. Or I'm going to put X minus 1 in there. Okay, so it does the steps, and you can verify if your graph is looking right. Okay, last thing on the paper is we are going to write a step function. Well, we're going to do a piecewise function for this admission rate. The admission rates at an amusement park are as follows. Children 5 years old and under are free. So you pay y, remember f of x is y will equal 0 if the kids are 5 or younger. So that would be between 0 and 5 years old. Does it include the 5? 5 and under, so it does. Oh, why did I make it between? I guess I put the 0 between 0 and 5 because are you going to have any negatives? Okay. Nobody's -8 years old, right? So I put it in. All right, children over 5 years and up to and including 12 years old are $5. So we'd have 5. Oops, I need a pen. So it's going to cost you $5 if your kids are between 5 and 12, including 12. So that's going to be 5 is less than x is less than or equal to 12. X is between 5 and 12, including 12, but not 5. Well, next they said that if you get to be 12 years and up to and including 18, so that means between 12 and 18. So when x is between, oh my gosh, pen, come here. When x is between 12 and 18, including 18, you got to pay $12 to get in. And then finally, when you're old and you can actually afford to go, you have to pay more. When you're an adult, you're going to pay 18. And that's when x is greater than 18. When you're older than 18. How exciting. You could graph that. All right, so that's it for step functions. Your practice and your assignment is worksheet 6AB and 7AB, which is the quiz preview, and our next quiz is in 2 days.